Okay, so I'm not able to do your Teams meeting today. It's pretty busy. Some of us are doing some interesting things. So um, I'm just going to kind of go through the bits and pieces that you need to know, okay, for the chemistry lesson that you would be having, okay, today. Now, I'll see you all in your Teams lessons tomorrow. And so if you've got any questions about this, obviously you can ask them then. But what we're going to look at today, okay, is we're going to look at 3 different types of material. Okay, we're going to look at polymers. Okay, we're going to look at ceramics, and we are going to look at composites. So that's your title. What are polymers, ceramics, and composites? Okay, and I'm going to quickly talk you through the difference between polymers, ceramics, and composites, and explain why we'd use each of these different things to make different objects. Now, there is a worksheet on Show My Homework that I'd like you to fill out. Okay, I don't want you to send it to me, otherwise I'm going to end up with most of the year's sheets. Okay, so if you're in my set, you can send it to me. Okay, but everyone else, you're going to wait for your teacher to put up an upload link. Okay, and then you can send it to your teacher. Okay, my class, the upload link will come up on Tuesday. All right. Okay, so look at this pan here. Okay, we use plastic handles. Okay, for our pans that we use in the oven, or on the oven, on the hob, or whatever. Okay, why do we use plastic here? Well, I'm hoping that some of you are kind of got there, but obviously we use plastic because metal conducts heat really, really well, and you don't want to pick up your pan handle and burn your hand. Okay, by using plastic, okay, we can stop the heat being conducted into the handle. Okay, it's a very good insulator, so we can pick up our pan without burning ourselves. Okay, the first thing you need to know about, okay, is polymers. Now, polymers, poly means many, okay, and the reason that we call these things polymers is that they are made up of many small bits of material. Okay, now those materials are various different molecules at the atomic level. Okay, and when we stick them together, we end up with a longer molecule. Okay, which is very, very long in a molecular sense, but obviously quite small in a like you wouldn't be able to see the molecules here. Okay, so polymers range from familiar synthetic plastics like polystyrene. Okay, and then there are natural polymers. Okay, things like DNA. Okay, again, it's a long repeating chain made up of lots of small bits. Okay, same with protein. Okay, here's why we might use them or what their properties are. Okay, almost all polymers, okay, are very resistant to chemicals because they've got this long kind of repeating chain. There's not a lot that the chemicals can stick to, okay, and react with. So they often end up being very, very resistant to chemicals. Okay, they're often very, very good thermal and electrical insulators. Okay, most plastic doesn't conduct electricity, and most plastic does not conduct heat. Okay, so almost all polymers are thermal and electrical insulators. Okay, generally speaking, polymers are very, very light in weight. Okay, and you might want to use a less light one to get a little bit more strength. Okay, think about the things that you have in your life that are made of plastic. Okay, there are things you want to be flimsy. Okay, there are things you want to be very, very light, and there are some stiffer plastics. Okay, that you would like, that you would want to use for things that you need to kind of hold their shape regardless of what happens. Okay, most polymers, okay, are reasonably tough. Okay, most polymers are waterproof. Okay, and depending on what polymer it is, okay, they can be pretty flexible as well. Okay, so polymers and plastics aren't always exactly the same thing. Okay, but in terms of you thinking about it, most polymers that you will have come across, okay, are going to be found in plastics. Okay, so here are some examples, some pictures. Okay, they're actually all made, okay, from something called polythene. Okay, now you would just call this plastic. Okay, but it's got a fancy name, polythene, which means it's made up of lots, poly, okay, of a molecule called ethene. So polythene. Okay, it's strong, it's tough, and it's waterproof. Now, the reason that plastic bag potentially might seem a bit flimsy is because it's made out of an incredibly thin layer. But if you were to have lots of that, okay, it'd be very, very strong. Okay, they're waterproof, okay, and they're pretty tough. Okay, it also doesn't conduct electricity, which is most of the time going to be pretty good for you. Okay, and it's flexible, which means that you can make it into different shapes. Okay, it can be moved around, okay, and not break. Okay, so the questions I'd like you to see if you can answer in your book, okay, are these. I'd like you to give one use of polythene that relies on it being strong. Okay, and you can use the internet if you need, okay, but I'd like you to give one use of polythene that relies on it being strong. Okay, and given I've just given you some properties of polythene, okay, I'd like you to tell me which of those properties you think make it a good cup. Okay, so that's polythene. Okay, there are synthetic polymers. Those are things that are made in a factory. Okay, they are made using chemicals. Okay, and then there are natural polymers. Okay, so here are some examples of some natural polymers. Okay, here we've got some cotton and some wool. Okay, and here we've got a silkworm and a ball of silk. Okay, these are all natural polymers. Okay, I'd like you in your book to give 2 examples of natural polymers and 2 examples of synthetic polymers. Obviously, these 3 are all natural polymers. Okay, these 3 are synthetic polymers. So here she's wearing a dress made out of probably wool, maybe a bit of lycra, maybe a bit of another polymer. Okay, the parachute here is made out of a number of different polymers, and the tights there are polymer tights. Okay, they are made of probably lycra. Okay, so final little task before we move on to the next one. Okay, to finish off polymers, okay, I'd just like you to have a think of some of the advantages and disadvantages of making the objects that are shown here from plastic, okay, and the advantages of making it from other materials. So the first one is your rulers. Okay, on the right hand side we've got bendy rulers, okay, or they could be just normal plastic rulers, but it's quite hard to tell from the picture, okay, versus wood. Okay, what's the advantage? Why might people rather use the wood than the polymer? Why would people maybe rather use the plastic than they would use the wood? Okay, similarly, you can make paintbrushes from wood and natural hair, okay, or just from plastic. Okay, so it's 2 different types of plastic on the right hand brush. The handle is one type of plastic and the bristles are a different type of plastic. And then finally, glass versus plastic bottles. Okay, what are the advantages and disadvantages? Now, I'm sure some of you will hit on the environmental impact. Okay, some of these things don't biodegrade. Okay, they don't break down when you put them in the ground. Okay, some of these things are made from a very, very depleting source. Okay, so you might be tempted not to make things from wood when you could make them from plastic. Okay, because we might not be able to get easy access to wood without chopping down even more trees, for example. Okay, so something for you to think of. See if you can write some answers to this in your book as well. Okay, so that was polymers. We're going to have a quick look at ceramics now. Okay, so ceramics are generally thought of as inorganic. Okay, that means that they don't really exist in nature, and they are non-metallic. Okay, so they're not metal. Okay, they're solid, and they have got a bunch of different useful properties, but particularly they are very, very hard. Okay, they are very they're reasonably strong. Okay, and they have got extremely high melting points. They also conduct electricity, and they also conduct heat. Okay, we tend to use ceramics for things like pans or pots. Okay, things like your china at home, that's ceramic. Okay, see if you can think of some. Okay, if you need to pause the video to give yourself a tiny bit more time, then do. Okay, see if you can think of some. I'd like you to see if you could write a list of 3. If you're not sure, you can use Google. Okay. I'm going to give you a little bit of a hand here. Okay. We've got some tiles. Okay. We've got mug, porcelain. So the sink and the toilet, they're probably made out of porcelain. Okay. The plate on the left-hand side, the ceramic pots in the top corner. Okay. For flowers. Okay. And a number of replacement teeth. Okay. Can be made from ceramics. So here we've got a little denture, okay, a little run of teeth there that might sit on top of kind of some bird down teeth that have fallen out already. Okay, so that's some ceramics. Okay, although they're quite strong, okay, they are quite brittle. Okay, so they don't bend. Okay, they just smash. Okay, and you'll know that if you've ever dropped a plate. Okay, although the plate is quite strong and you're not going to be able to snap it, okay, if you drop it, it's likely to shatter. That makes it brittle. Okay, if you don't drop it, okay, ceramics are very, very durable. They last a long time, providing you don't drop them on the floor. Okay, and they don't conduct the heat very well, but they retain the heat. Okay, so once they've got hot, they stay hot for a very, very long time. Okay, so that is ceramics. Okay, try and think of an advantage and disadvantage of making some of these objects out of ceramics or out of another material. Okay, so here you go. You've got a plate made of plastic on the right, a plate made of ceramic on the left. Okay, what might be the advantage of making it out of plastic? What might be a disadvantage? Okay, and on the at the bottom there, what about a metal toilet bowl, okay, versus a ceramic toilet bowl? What's the advantage? What's the disadvantage of each of those options? Okay, composites. Okay, so the last one. Okay, so we've looked at polymers, we've looked at ceramics. Okay, the last one is composites. Now, composites is kind of a bit of a funny one here because composites are made by combining 2 or more materials. They can be man-made, they can be artificial, okay, or they can be natural. You can find them in nature, or we could construct them from things that we find in nature. Okay, but 2 or more things that we combine together in some way, okay, to make best use of each of their individual properties, okay, or to minimize their weaknesses. Okay, let me give you some examples. Okay, here we've got a composite tooth filling, okay, or some composite plywood. Now, a single layer of plywood on its own, okay, is one, very, very cheap, okay, because it's made out of cheap wood, okay, and it's pretty flimsy, it'll bend, okay, and it'll probably snap. By sticking lots of them together, okay, I end up with something that's composite, okay, it's made up of lots of different types of wood. You can see that down the side there, okay, you've got some lighter wood, some darker wood, okay, you get the benefits of both of those by sticking them all together into a big wood sandwich. Okay, it's a composite bit of plywood. Okay, and on the left hand side you've got composite tooth filling. Now, by using different things here, okay, you could improve the strength of the particular material you're using. You could make it a bit harder. Okay, it might be that one is easier to melt. Okay, and so by mixing them together, you don't have to have it quite the right, quite as hot a temperature when you're putting it into someone's mouth, because that'd be awkward. Okay, those kinds of things. Okay, we're taking 2 different things, or possibly more than 2 things, and we're combining them together to change the overall properties. Okay, here's another example, right? This coat, okay, it's a rain mac. Okay, so Charles Mackintosh invented the rain mac. Okay, and he basically took 2 layers of cotton, okay, that was reasonably comfortable, okay, and sandwiched them with a layer of rubber in the middle. Okay, and so in this case we get the waterproofness of the layer from of the layer of rubber, okay, combined with the comfort and the feel of cotton, okay, which therefore means that it not only keeps you dry, but is not that uncomfortable to wear. Okay, whereas if you were to just wear a coat made out of rubber, okay, it'd be very, very uncomfortable indeed. You'd be very, very warm, all of the time. It'd be pretty horrible, really. Okay, but by putting those 2 layers of cotton around the waterproof layer of rubber, okay, we end up with a more comfortable, better raincoat. Okay, now I'm going to give you a whole bunch of information on the next slide. Okay, I'm going to give you the information, and I'd like you to come up with some composites. Okay, what would you call them? What would they be used for? Okay, try and think of 2 or possibly 3. Okay, let me give you one example here. Okay, let me give you one example. On this sheet here, okay, we've got things like plastic, okay, and we've got things like iron. Okay, so let's say I would like to make a wire, okay, to carry some electricity from the plug socket to whatever it is that I'd like to electrify and give some electricity. Okay, now if you've got a wire, you'll know that it's got that plastic layer around the outside. Okay, plastic is a terrible conductor of electricity. It's a fantastic insulator, so I can hold the outside of my wire to my heart's content without electrifying myself. Okay, however, okay, iron conducts electricity because it's a metal. Okay, so running through the middle of my wire, I could use iron. Now, I might not want to use iron because iron isn't really stretchy and bendy. Okay, not like something like copper, but if I can make the pieces of iron thin enough, then I could get it to conduct. Okay, copper is a better conductor, okay, which is why we use it, and so that's why we use copper. It's also not magnetic, okay, whereas iron is. But you could make a wire from iron and plastic, okay, and so that material would be classed as a composite. It's made up of more than one different type of material, and the 2 different parts of that, okay, serve different functions. The plastic is very good at insulating, okay, the iron very good at conducting, okay, and the combination of those 2 things provides me with a material that is much better overall than using just one. Okay, so guys, there are some questions in there that I need you to fill in. Okay, I need you to fill in the sheet that is on Show My Homework. Okay, and I'd like you to come up with 2 or 3 different composites using the stuff that is on this page at the moment. Okay, or something else. I don't mind as long as it's clear. Okay, so I'm just going to go through that again. I'd like you, please, to answer all the questions that are on this PowerPoint. Okay, to come up with 2 or 3 composites using the stuff on this slide. Okay, and I also need you to fill in the sheet on Show My Homework, okay, with all of the bits and pieces from this PowerPoint that we've already been through. Okay, so the properties and that sort of thing. Okay, don't submit it to me. Okay, submit it to your teacher when they put up their Show My Homework task. Okay, which will probably be on Tuesday. Guys, there will be a Teams meeting on Tuesday. Okay, there will be a Teams meeting on Tuesday. I don't necessarily know who is going to take it. Okay, my 3 groups that normally have me, okay, it will be me. Okay, but everyone else, I'm not entirely sure who's going to have you. Okay, in that meeting, okay, we are going to be finishing this stuff. Okay, in that meeting, we're going to be finishing this stuff. Okay, so if you've got any questions or you don't understand, you can bring your questions to that meeting. Okay, guys, thank you very much for listening. I will see you soon.